My name's Zane, and I'm a computer science and applied math student at the University of Southern California.
Hi, I'm Leena. I'm a rising junior at the University of Southern California, studying computer science and cognitive science.
I asked you here to talk about your project, the Endangered Language Project. Can you give us a high-level summary of what it is?
Our project looks at using unsupervised learning to assist in classifying phonemes of endangered languages.
So you guys both have different academic backgrounds. Could you each speak to how your skill sets were brought to bear into the project?
Naturally, computer science was very helpful for any sort of machine learning task, because a lot of what you're doing is programming and learning how to use different frameworks. We mainly used PyTorch because we were sort of messing around with doing autoencoders a little bit differently than maybe some standardized model, which TensorFlow might be better for. And also my applied math major really helped me unpack some of the literature that we were reading on the subject and sort of try to make sense of it all.
Yeah, and I'm a computer science major as well. And so that helped me along with the machine learning part and the implementations part of this project. But I'm also a cognitive science major, and that's what really motivated me to choose to work on this project in the first place, because that's an interdisciplinary study of the mind and its processes. I've taken classes in linguistics, psychology, philosophy, and this project motivated me to go further in linguistics. So actually next semester I'm taking class in syntax, because the language itself is so fascinating, not just in its production, but also the study of its structure.
What does it mean for a language to go extinct?
Essentially, I guess the technical definition would be the last living speaker of the language dies, and that assumes they haven't passed down the language to their community. And it's quite prevalent now because mainly due to forces such as globalization, which reduced the necessity for knowing these like niche languages in different parts of the world.
And what designation does Latin have in that regard?
Yeah, it seems like it is an extinct language in that there are no longer any living speakers, even though it is still in use. It falls into this category of an extinct language.
So I guess it's a very well-documented extinct language.
Maybe that's the distinction, yeah. Is that perhaps the level you guys want to ascend all of the languages you're working on? Or is there some other objective? What's the preservation efforts end goal?
Well, I guess from our end, it would be helping out the linguists in transcribing the language, because they go out to these fields and they don't know the language. They talk to speakers, they get the audio, and they try to take down the phonemes, the essential sounds that the language is made up of. But there's also, of course, in some communities, there's a more sociological approach to preserving the language. For example, the language we deal with is called Ladin, which is spoken by about 20,000 people in the Italian Alps. There is a team of linguists trying to preserve it, but there's also community efforts to try to teach it to kids so that they can carry it on.
What is a phoneme?
A phoneme is the basic unit of sound in speech. So say I say the name Steve, S, T, E, and V, and the V sound, those are all the phonemes in that word.
How do those phonemes vary language to language?
Yeah, so there's actually a lot of variance between different languages, and some languages will vary more than others. So for instance, languages that are very similar sounding, like say Spanish, Italian, or maybe even Portuguese, will share a lot more phonemes than languages that are more different, like say Chinese versus Russian.
And how did you guys get interested in Ladin as a language?
This was a project that our professor we were working with had already started on, but I actually was very interested in it because my father speaks a dying Italian dialect, but it's Venetian, so it's not Ladin. But I sort of was very interested in the project because I sort of had a personal connection to it.
And can you tell me some of the characteristics of the language? I'd imagine most listeners will not have heard it. I don't know that you guys picked up any along the way, but what's it similar to?
It's very similar to Italian. I'm taking Italian classes at USC, and I could actually understand a decent amount of the language just from listening to the audio data, but they'll sort of have certain words that are different than normal Italian, and also sort of certain, like maybe conjugation methods are different also.
It's also very similar to Swiss Romansh, especially because it's spoken by this community in the very northern part of Italy, really at the border of the intersection of Switzerland, Italy, and parts of like Austria.
Oh, and is there any possibility we could use a clip of one of the Ladin speakers?
Yeah, here we have some.
Allora, Stefania, volete domandare che la cosina la mamma a casa, de solito. E se tu pensi, insomma, ne contar en mingle, che tu mangi de solito a casa. E co che ven così, ne, che chi spiace.
So tell me a little bit more about the data set that was collected.
So we have 3.5 hours of audio data collected across 4 speakers, and that's the Ladine data. And it was collected by our professor last summer, along with the team of USC students in Bolzano, which is in the area next to where Ladine is spoken.
So I guess that's enough data to be working with for sure. But like anything, you'd probably appreciate a larger data set. In what way actually would you like it larger? Just more duration or more speakers, or what would be most valuable to continued research?
More speakers would probably be the most valuable asset that we could use to improve our data set. We are only working with 4 speakers. We sort of run into this artificially high accuracy problem because all the speakers are more or less speaking the same way, and compared to data sets that include hundreds of speakers, our phonemes sound a lot more similar when it's just the same people saying them.
There's such a large variation in speech across like different ages, genders. So it would be cool to have a more diverse subset of people speaking Ladine so our models could better generalize across the variation.
And I'd love to hear a little bit about the end-to-end process. Obviously, your input can be something like maybe a WAV file or an MP3 or whatever. What are you delivering then as your final output?
Our final output would be recommended start and stop times and unsupervised labels for the phonemes that correspond to those start and stop times. That would be the final output from the pipeline, but in use, if a certain unsupervised label is highly correspondent with a specific phoneme, that would turn into a recommendation for that phoneme starting and stopping at those times.
Do you handle that, those two problems simultaneously, or is there an effort to first divide it up and then classify the phoneme?
So we slice our audio file into many small segments, and then we'll actually label each of those small segments with the unsupervised label, and then we'll combine adjacent segments so that it is actually all in sort of one process to get the label with the start and stop times.
And I'd love to hear a little bit about the architecture and sort of the algorithms used. How did you end up building the classifier?
Our classifier is just a more or less a simple neural network. As input, it takes a series of vectors, and each one of these vectors is basically a condensed representation of. So we use an autoencoder to get a condensed encoding of a segment of audio data, and then we grab many segments in a row and then get their condensed representations and combine them as input to our classifier.
So you said it's unsupervised, but you want to classify them. How can you reconcile those two ideas?
Yeah, so we want to classify phonemes, but we also want it to be unsupervised. So basically what we're trying to do is create a system that can sort of recommend what is the most likely classification of a phoneme, given perhaps other phonemes that you've already labeled. So and basically this would be used alongside a human. We aim to assist humans in transcribing speech. So they'll need to know when certain phonemes start and stop. And our idea is to give them a sort of best guess as to what the phoneme is and what the start and stop times are, to sort of assist the process of language transcription, specifically with endangered languages.
And the reason we care about this is because there's a global effort right now by linguists to go out in the field, document languages, and transcribe them, because there are currently 7,000 spoken languages, but it's estimated that at least half of them will go extinct by the end of the century. The manual transcription process can be quite tedious, so we hope that our system can assist the human in transcribing languages, because it takes quite a long time to transcribe the actual phonemes to preserve the language.
And then tell me a little bit about the neural network architecture.
So it was a simple 2-layer neural network model. The main purpose of our experiments so far hasn't so much been like playing around with the architecture of the classifier. It was mainly using autoencoders and RBMs to extract representations. And then the classifier was just a simple 2-layer neural network to just like see what the accuracy of those representations were in classifying the phonemes.
For so many of us, school was about cultivating the skills we'd use most in our careers. But there's so much to be gained from learning skills that can also enhance our daily lives. That's why I want you to check out the Great Courses Plus. This service offers a huge library of audio and visual courses on just about any topic you can imagine. They're all delivered by experts who present the materials in a way that's both fun and fascinating. Explore everything from boosting your emotional intelligence or learning Spanish to gardening or photography. And with the Great Courses Plus, you can learn on any device, and it's completely on your schedule. And here's an interesting wildcard suggestion. Why don't you check out the Effective Communication Skills course? Not something most data scientists, data engineers, and analysts and people who generally congregate to the show, not necessarily a skill that they've developed well, per se. It's not always in our training. This course provides insights into how we communicate, gives practical tips to becoming a more active listener, better manage reactions, and speak more effectively. This is key to communicating with your colleagues. So check out our special offer. Make the Great Courses Plus your go-to for lifelong learning. Right now they're offering my listeners a free trial of unlimited access to their entire library. Access this offer now by signing up through my special URL. It's thegreatcoursesplus.com/data. One more time, thegreatcoursesplus.com/data. You'd mentioned using RBMs. Could you unpack the I don't know if it's an anagram. It's not an anagram. What is that?
Acronym. Yeah.
Yeah, it stands for a restricted Boltzmann machine. We initially started with that because that was the first architecture that was used for segment recognition by Jeff Hinton's group. Of course, he stacked them into deep Boltzmann machines as well. But we tried that out to extract, I think it was 120. I can't remember how many features we extracted through our RBMs, but we tried that out first to see if we could actually extract meaningful representations. And then we shifted our focus to autoencoders after that.
And can you tell me a little bit about the diagnostics? You'd mentioned earlier that it sounds like maybe there was some overfitting that you're aware of, but what sort of level of accuracy and things like that did you encounter?
In the end, our classifier got a 50% accuracy in classifying the phoneme into the correct category. So the baseline for unsupervised methods is around 20 to 30% in academia. And so this is sort of when I was mentioning earlier, we had a very high inflated accuracy sort of. This is, I think, the main cause of it is because of our lack of speakers.
Tell me a little bit about the training process. Like, how long do you train it for and how quickly does it converge? Just what were some of the general experiences in building the model?
Yeah, so for the training process, it actually took a very long time to converge because we wanted to grab every possible segment of 100 audio bits in our audio data, which, I mean, if you can imagine only having like 7 minutes of audio data, you already have millions of possible segments. So utilizing all of our data, running just one epoch took many hours. So it took a very long time, but we did notice a very sort of standard convergence using autoencoders where you sort of get that nice sort of reach a point of diminishing returns after a while.
So I remember one other undergrad on our team, he left his model running over spring break and it still wasn't done.
Gotcha. Yeah, pretty typical. You could, in terms of making improvements on the accuracy, you could target lots of areas. Perhaps you could, even get better microphones and say you increase the fidelity of the recordings and maybe that would help, or increase the sample rate, who knows. You could work on the data pipeline or the algorithms. What are some of the areas you think would be most fruitful in that regard for improving accuracy?
I think that our sort of final classifier is very minimal, very bare bones. And I think if we wanted to try to improve our accuracy in classifying phonemes, this would be a very great place to start. Also, in terms of our autoencoder, I think it could be improved as well. I think there are different models such as noisy autoencoders, which I think are very typically used for speech problems, but we went with a more standard model.
I'm also interested in maybe if we implemented a recurrent autoencoder, because I don't think at the moment we're taking advantage of the temporal aspect of data as much as we could. So maybe some more models that take advantage of the fact that the sounds produced are in specific sequences. So sequences of segments as opposed to segment.
Yeah, that does sound very promising. One of the features I notice a lot in language is what I call stalling, and maybe a linguist has a more specific term for this, but I could say, I don't know, something like say and hold it out, and I've kind of delayed it, I guess, while I'm thinking. or maybe there's ways people express meaning by holding stuff. I don't know. But certainly we can stretch the phonemes. How does your system perform under those tricky situations?
So I guess we try to address that by combining the nearby vectors to try to capture the longer term. But in the future, we will try to implement a more temporally based model. So maybe an RNN to try to capture, because language itself, a segment unfolds in time. It's essentially a temporal problem. So we will try to capture that in the future.
That is also just a problem. For a lot of different phonemes, they will be similar at the end, but different at the beginning. So, for instance, O versus ow, I believe they're different at the very beginning, but if you stretch out the ow, it just sort of turns into an O. So that could potentially be a problem for more or less any system.
And I'm curious to hear how your work fits in with the workflow of the whole project. You'd mentioned that right now they're trying to, I guess, manually annotate these. Will your software replace humans or make humans more efficient? What's the end goal?
Definitely make humans more efficient.
What's the motivation or restriction as to why you can't 100% automate?
So a major limitation of working with endangered languages is that you have very little training data. If you wanted to create some sort of 100% accurate model to completely annotate it. So since your problem really fundamentally is a lack of training data, that sort of was the reason why we had an unsupervised approach to it. Also, unsupervised labels as output from our software would sort of be used in conjunction with a human interpreter to sort of actually create the final phonemes labels.
And where does all of the output then live? Do you guys store these in some specialized database, or how do you process and preserve this information?
For the most part, phoneme start and end times and labels are more or less just kept in text file format. There's a specific file extension name that I can't remember right now, but it's more or less just raw text in a file.
And how did you guys get involved in this project in the first place?
So we're both part of CAIS++, which is USC's undergraduate branch of the Center for Artificial Intelligence in Society. That's called CAIS. They're a research lab that's a collaboration between USC's engineering school and the School of Social Work. But we're a student group, and we have the same motto as them, which is AI for social good. So we collaborate with USC professors and community organizations to apply AI to various problems that all have to have a social good component. And so our center, we sourced the project with Professor Iskaros, who was interested in having a team of undergrads apply machine learning to this problem of speech segmentation for endangered languages.
What are some of the other efforts that the club has been working on?
Some of the projects that we had this semester was trying to incorporate fairness into machine learning models like Word2Vec. We were also using Airbnb reviews and natural language processing to try to predict gentrification in neighborhoods in New York.
What are some of your guys' aspirations for where this project may go next?
Our professor is back in Italy this summer with another group of USC students collecting more data with regards to Ladine. In the near future, we could hopefully incorporate that new data to improve our models, and hopefully, if there's more diversity in that data, to generalize across more diverse subsets of people. But I guess long-term, we'd like to transform this into a system that could be used by teams of linguists out in the field to assist them while they're transcribing audio of languages.
We're going to write our findings in a paper this summer and submit it to a JASA EL segment, which is a audio speech express letter, not a paper. But it's a journalistic journal that focuses on acoustics and language.
The Journal of the Acoustical Society of America.
Well, to close off, tell me a little bit about where you guys are going kind of academically. What's next for both of you?
Well, I guess for me, I'm planning on going straight to PhD after undergrad, probably in a machine learning or a different subfield of AI.
Yeah, similar with me. I'm very much considering going to grad school or PhD. But I mean, at the same time, just going directly into the field is also something I might be interested in. I'm not entirely sure, but I think either way, you can make meaningful contributions and have a really interesting time solving interesting problems.
Do you have an online presence? Is there any place people can follow you?
I guess people could follow the CAIS++ Instagram or Twitter, but At least for me, I don't use social media.
Well, thank you both so much for taking the time to come on and chat with me.
Thanks so much for having us.
Thanks for having us.